Okay, 4.7 inverse trig functions. So the functions we're going to look at are sine, cosine, and tangent. Oh, I wanted to do this because we know these go on this way, right? Yes? Mm-hmm. Okay, so that's what we're going to look at. Now, you guys, I actually had this discussion with somebody yesterday how I hate that books will tell you these functions have no inverses. They have inverses. Their inverses are not functions. Okay, do you remember how to look at a graph and say whether something is a function or not? What line test do we use for that?
Vertical.
Vertical, right? So are all of these functions?
Yes.
Yes. But remember, the horizontal tells me if its inverse is a function, right? Mm-hmm. So all of these fail the horizontal, don't they? Mm-hmm. Okay. So they all have inverses. They just don't have inverse functions. Make sense? So we also know, I'm just going to use cosine because it's in the middle, that this is 0, yes? And this is pi over 2. And this is 3 pi over 2. And this is 2 pi. Yes?
Yes.
So in between a max and a 0 is a quadrant. So that's quadrant 1. And this is quadrant 2. Wait, this is quadrant 2, and this is quadrant 4. Why am I off? Anyway. Oh yeah, I needed that. My graph is not pretty. So I have Q1, Q2, Q3, and Q4, correct? Mm-hmm. So if there are things I like, could I cut this graph somewhere? What happens if I did this? And said none of this exists anymore and none of this exists anymore. Does that have all the positive and negative values of cosine you could have? Yes. Yeah? It has everything, doesn't it? Mm-hmm. Now, does this piece pass the vertical line test?
No. Yes.
Yes. Does it pass the horizontal line test? Mm-hmm. Yes. So if I restrict the domain for cosine from 0 to where's this at? Oh. Don't look at what I wrote. Where's pi? If I restrict it to that, does cosine have an inverse function? Yes. So what quadrants are from 0 to pi? Quadrant 1 and what? 2. So our rules are, in restricting these domains, they have to be consecutive quadrants. What's that mean? What does consecutive mean? Connecting, continuous. So it can't be quadrant 1 and 3, can it? Or quadrant 1 and 3 consecutive? No. Okay, and it has to include quadrant 1. So our choices are to reduce it to quadrant 1 and quadrant 2, or quadrant 1 and quadrant 4. So in a picture of the circle, cosine now only exists in quadrant 1 and quadrant 2. So from 0 to pi. Does 3 pi over 2 exist in the world of cosine anymore? No. It's like Christopher Columbus sailing off the edge of the earth. He can't come back.
Okay.
Got it?
That makes sense.
Okay, so that means we have to work on sine and tangent. The reason, you'll see why I picked cosine in a second. Okay, so now I'm going to go to sine. So remember, I need all the positives and all the negatives. They have to be consecutive quadrants, and I have to include quadrant what? 1. So 1 is right here. Yes? So cosine, I did quadrant 1 and quadrant 2. What's wrong with doing quadrant 1 and quadrant 2 for sine? Quadrant 1 and quadrant 2. There's not one negative in there. And does quadrant 1 and 2 fail the horizontal line test? Yes. So I can't go forward. I have to go what? Backwards. To quadrant what? Not 2.
-2.
Quadrant
3. 4.
4.
4.
Doesn't quadrant 4 connect to quadrant 1?
No.
Inner circle, guys. Q1. Q what?
2.
4.
Oh, you're going that way. I go this way.
No, that's wrong.
How?
Because this is 2
Yeah, so
and
I
this
said.
is 3. But we already
1, 2, 3,
identified. We
4.
already identified quadrant 2 didn't work.
So
We said quadrant 2 didn't work.
So the only other one that can work is
The only other one that could work is 4. Do I have all the positives?
Yep.
Do I have all the negatives?
Yep.
So all this is gone. And quadrant 2 and 3 is gone. So the only thing I can do is go up to where? What's this?
90.
Nope. Radians. Only graph in radians. Pi over 2. And down. I went down, so that's a negative angle, yes? Negative what? Pi over 2. So our domain is x such that pi over 2 is less than equal to x, which is less than equal to, oh, that's negative pi over 2. I went from biggest to smallest. That was bad, wasn't it? Does that make sense how we did that?
No.
Okay, what does make sense about it?
How you're figuring it out because I'm just confused.
Okay. So, going off of what we did for cosine, this is quadrant 1 and quadrant 2. We discussed that that doesn't work because all we'd have are positive answers, and we know there's negative answers. So this over here does not work. Okay?
How are you telling if there's only positive?
Right here. Isn't this graph only positive? Aren't all
Oh,
these
so
y values positive?
If it goes into the positive, like the line goes into the positive and negative, then you know
Yeah, because you have to have all the positive solutions and all the negative. So quadrant 2 didn't work because that gave me 2 positive answers, and I can't have that. So then I have to unwind my graph and look what happens. Do I get all my negative answers then? Because they're below the x-axis. Are all my negative answers there? Mm-hmm. Yes. So this is gone. So that gives me quadrant 1 and quadrant 4. Do I have the same shape as I do with cosine?
Yeah.
Essentially, right? They just face each other, right? But now I'm just in quadrant 1 and quadrant 4. So I can rise to pi over 2, or I can fall to what?
negative.
Negative pi over 2. But nothing else exists.
And you know it's negative pi over 2 because of.
Because I went backwards because this is 0. Does that help if I put 0
So will
on
it
there?
tell us if it's going by, like what it's going by? If it's going by like negative pi over 2 or negative.
You have to figure that out.
Okay.
Okay? So when I want negative values, it's going to be where? In the 4th quadrant. When I want positive values, it's going to be in the what?
Quadrant 1.
Quadrant 1. Cosine, when I want positive values, it's going to be in the what quadrant? First. When I want negative, it's going to be in the what?
Second.
Second. Here, I'll put a positive. I will only have one answer. Because before today, when I said the sine of x equaled 1/2, there were 2 answers to that, yes?
Yeah.
There was x equals pi over 6 and 5 pi over 6. Okay, now today, the only one that exists is what?
5 or 6.
Pi over 6. Why does 5 pi not exist?
Because it's in quadrant 2.
It's in quadrant 2, and we've said that doesn't exist anymore. If I want the sine of x equals negative pi over negative 1/2, we used to say, bless you, x was 7 pi over 6 and 11 pi over 6. Neither one of those exists anymore. Because to get to 7 pi over 6, I have to go this way, don't I? Does quadrant 2 exist? No. So I can't get to quadrant 3. And if I can't go through 2 or 3, can I get to 4 from this direction? No, the only way I can get to 4 is to what? Drop? So the answer would be none of these. It would be x equals negative pi over 6. Because you have to drop. Sine is actually pretty easy. Because since we're rising to pi over 2 or dropping to negative pi over 2, all I have to do is, if I know the positive, all you have to do is put a negative and you got it.
Okay.
Okay, now we need to do tangent. So in tangent, let's see. We've got asymptotes, right, for our quadrants. So this is Q1. This is Q2 from the 0 right here. So Q2, Q3, yeah. And then I'd have to start a new one for Q4, wouldn't I?
Mm-hmm.
That way. But can't I unwind and get to Q4 here?
Yeah.
So this is Q4. Is the unwinding bothering you guys?
No.
Okay. Get how that works? Like you go forward, 1, 2, 3, 4. So you go backwards, 4, 3, 2, 1. Like that.
Yes.
Okay. So I have to include quadrant 1. It has all the positive values, yes?
Mm-hmm.
I'm going to tell you that the graph has to be consecutive. Okay? That means, or continuous. That means no holes or breaks, right? So can I go to quadrant 2?
No.
Because there's an asymptote there, right?
Yeah.
So that means I have to go back to what?
Q4.
Quadrant 4. Now, I will tell you, so that domain matches what? Doesn't it match here?
Yes.
Yep. So it will rise to pi over 2 and fall to negative pi over 2. So x such that negative pi over 2 is less than equal to x, which is less than equal to pi over 2. I will tell you there are books that use this. I don't like it. First of all, both sine and cosine are odd functions, yes?
Mm-hmm.
Okay? They're both odd functions, so it makes sense for them to match their domains when we're limiting. But if I told you some books use this, does that give me all the positive and negatives?
Yes.
It does, doesn't it? Okay? See that?
So do they don't have to be connected for it to...
They are consecutive quadrants. But, oh, you mean continuous, the graph?
Yeah.
No, they don't. What I'm trying to show you is, could you limit this to anywhere you wanted that had all the positives and all the negatives?
Yep.
Yes. Could I come clear over here? So this is pi. Could I do it from pi to 2 pi? Yes? Do you see that?
Mm-hmm.
I'm trying to make it easier for you guys to say it has to include the first quadrant, because then we know everything is positive in the first quadrant, don't we? So it kind of makes it easier to hold on to. You can essentially limit to anywhere you want, but it has to include both all the positives and all the negatives, and they do have to be consecutive quadrants. They can't skip a quadrant. What else do I need? Is that it for that? So this is quadrant 1 and quadrant 4. So when you guys start, this is what I do to remember. If I get on my test, I would say sine / tangent, and I would do this. Pi over 2 to what? Negative pi over 2. You can't go all the way around because this doesn't exist anymore. And then I would write cosine from 0 to what? 0 to pi. All the positives are in the first quadrant. All the negatives are either in the fourth or in the second. Does this tell you right here where you can tell me an angle is at? Yes. And remember, 11 pi over 6 no longer exists. What is 11 pi over 6? What's the coterminal to that when it drops? Negative pi over 6. Those are coterminal angles, aren't they? At the same terminal side. We have final review right here. We're going through. Okay. And we got that? No. Okay. Let me know when you're good.
Should that pi be negative on cosine?
No. Because this is a positive direction.
Oh, okay.
Okay. So the next part I'm going to do, you do not need to write. I just want to show it to you. Okay? So if I limit and just draw what it looks like. This is sine. Oops. Right here. You can see this blue highlighter, right? Pretty good? Bless you. Okay. That is inverse sine. Remember, inverse is just that -1. So cosine looks like that. This is going to be weird. My brain doesn't want to do it.
Me either.
Cosine looks like this. Now, if I moved inverse cosine, if I moved this down and over, would it do the same thing?
Yeah.
Yes. It just happens to go a little bit different because this one goes up to pi, which is much bigger than 1, isn't it?
Mm-hmm.
Yeah. Tangent. Tangent looks like this. And cotangent looks like this. Not cotangent, inverse tangent. You aren't going to have to graph them. I was just showing you. Okay? That's why I said you don't need to write those down. If you want to look at them, they're in the book. But they don't have both graphs together, and it's really kind of weird to me. If you look at cosine, it kind of looks like DNA, and when they do them both together. So what we're going to do is with that, what that means for us is we're going to do the same with this example. So we'll do more. The two ways to write inverses. So we can have the inverse sine with the -1. And you can also have arc sine. They both mean inverses. I don't like to write arc cosecant because that just drives me nuts. Arc is not my go-to. This is my go-to. But you need to know that both mean inverses, okay? The book will use both. Arc, cosine of negative square root of 3 over 2. So that means I want the x. I want the angle. Yes? Okay. So anytime they are negative, I want you to identify the reference angle. Okay, so theta hat is pi over 6. And we are in radians unless they tell you. So our reference angle is pi over 6. So we're in the second quadrant for negative, yes? So what's pi over 6 in the second quadrant? No, I don't want root degrees. Won't even take them. Nope. 5 pi over 6. How did you get 5 pi over 6? You mean subtract 1? Because we know we're going to the second quadrant. We're going 2 pi, yes?
Oh, yes.
And we're 1 less than that. So it's going to be 1 less than a whole would be what? 5. Degrees will get you 2 points off on this test. If you give it to me in degrees and I don't want degrees. Got it? Because we're at the point we should be able to just say interchange in your head. When you hear 30, should you be thinking pi over 6? Yes. Okay, inverse tangent, a -1. So, equals x. They don't have equals x, I always do it. So remember, tangent is up to what? Pi over 2 or down to negative pi over 2. So, what's my reference angle? Because it's negative. Where's tangent 1 at?
Wait, what did you ask?
Where's tangent 1 at?
4.
Pi over 4.
Sure.
We're using fourth quadrant. Pi over 4, guys. Isn't tangent 1 at 45? Hello.
Hi.
We tomorrow will have a test over exact values. A test. It will be a test grade tomorrow. 45, tangent is 1 at. Yes? Because the x and the y are the same. Square root of 2, square root of 2, which is 1. So, I want the negative, so that means I have to drop to what?
Negative pi over 4.
Negative pi over 4. Okay, this is, you have to know your exact values to do these. Okay, then I have sine of the inverse sine of 1/2. So sine of the inverse sine of 1/2. So this is asking for an angle, correct? Inverse asks for an angle. And this is asking for a value. Order of operations tells me I have to do parentheses first, then the outside, correct? So this one asks, where is sine 1/2 at? So where is sine 1/2 at? Radians? Pi over 2. And this one says, what is the sine at pi over 2? Oh, wait, not 90. Sine is not 1/2 at 90. Sine is 1 at 90. So radians? Pi over 6. Okay, so it asks me what angle is sine 1/2 at? It's pi over 6. So now what's the sine of pi over 6? That's an angle. What's the value? What's the ratio of the sine of pi over 6?
It's not negative pi over 6, is it?
No, those are angles. I want values. It's 1 over 2.
Oh,
It's 1/2.
What we just had.
Yes. Why?
Is it confusing?
They undo each other, don't they? Do these not undo each other?
yeah.
Perfect.
So
Yes.
couldn't you just cross them out and just keep doing it?
Yes. But you had to learn that first. And it's pretty scary that you guys don't know that at pi over 6, that this is 1, 2, and square root of 3. Should you know that?
Yeah.
Yes.
I didn't know.
Well, then why didn't you say 1/2?
Because I'm not thinking about that.
But that's what you're supposed to be thinking about. Okay? So what if I have the inverse sine of the sine of 135?
It's
Now-
135 degrees.
But it has to be like
No. This one is in degrees. Why? Because I gave it to you in what? Degrees. If I don't tell you or I didn't give it to you in degrees, you better be giving it to me in radians. So let's do the whole process again. What is the sine at 135 degrees? Well, that's the reference angle.
So pi over the square root of 2. I don't know.
Half right. No, you're half right. So this is 45, yes. Square root of 2, square root of 2, and 2. So what is the sine? So we have the inverse sine of square root of 2 over 2.
And then that equals 135 degrees.
Nope.
What do you mean no?
Does sine exist at 135 degrees anymore?
No.
No. Where's it going to give me the positive square root of 2 over 2? Where it exists. Where sine exists. Quadrant 1 and 4. So what angle, you guys have it on the paper already, what angle is square root of 2 over 2 in the first quadrant? Because that's where it's positive.
Shouldn't that be
45.
here at 4?
Oh, yes. Okay, so that's kind of a trick question, isn't it?
Yeah.
Because they gave you 135, but once I take the inverse, does second quadrant exist anymore for sine?
No.
No. Pesky things.
I'm done. I want to go back to Monday, Tuesday, Wednesday.
So that's why we're doing every other odd today and every other odd tomorrow. So we can, you know what I mean, see everything today and tomorrow. Why couldn't it be 135 again?
Because it doesn't exist. At
Because it does
135.
exist. So basically it is 135, but you have to find the 135 angle.
In quadrant 4.
Right. So what if I said the inverse sine, and this goes for cosine too. Here, we'll do cosine. So the inverse cosine of the cosine of 315. Okay, without restricted domains, you'd say 315, right?
Nope, not anymore.
But you can't. So what is the cosine at 315?
Pi over 3.
2 square root of 2 over 2.
But 315.
Right, 45.
Where's 315 at?
And the fourth quadrant.
So is it positive or negative?
Negative.
Oh, wait, it's positive. I didn't want that one. 225. I want a negative.
Ma'am.
I was thinking sine when I picked 315.
I would have known that if it was 315.
Yeah. Okay, so this would be negative, yes? Yes?
Yep.
So it'd be negative square root of 2 over 2. So then where is cosine negative at that it exists anymore? Because you only have quadrant 1 or 2, so where's it negative at? What? 2, because everything's positive over there, right? So it's negative over here and positive over here. So what angle is over here that gives you square root of 2 over 2? We're in degrees, right? So this is 180, 135. Because you took 45, 180 minus 45. Well, you should have taken 180 minus 45. So when you give your final answer, you have to make sure you're in those restricted domains, okay? So up here, we had to say something that was in. We start with something that's in my restricted domain because the inverse is done first. Make sense what I'm doing?
Yes.
Here, I have to find a final answer.
All done.
Does this go for tangent also?
Yep.
The inverse tangent of 3/4. Oh, ooh, no. I want the sine of the inverse tangent of 3/4. We got to do this one, and then we will be all done. Okay. So these don't match. These match. These do not match.
Yep.
Okay. So does this? Could I draw a triangle with this information?
Yep.
Yes.
Yeah.
That triangle would be in the first quadrant.
Mm-hmm.
So I draw a triangle. And here's theta. We don't know what theta is, do we?
No.
Okay. And this is opposite over adjacent. So 3 over 4. So this is a 3, 4, 5 triangle. And now it wants a sine of that triangle. So I drew the triangle with this. That gave me the triangle. Now use the triangle to find the sine. So what would the sine be?
4 over 3.
Sine 3
Over 5.
over 5. 4 over 3 would be the cosine, cotangent. Everyone see what just happened?
Yep.
Do we need to do another one of those?
Nope. No.
We drew our circle, or drew our triangle with the first part, right? And then use that triangle to find the sine.
I think it was going to be 3, 4, 5.
No, of course not.
think you're fine.
How are you supposed to find the other side? What are you supposed to use if you only have two sides of a triangle? What?
So, if it's stupid.
Pythagorean theorem?